Right, question 10. So, for part A, let's always resolve vertically and horizontally. So, vertically, we've got that S is equal to 1, U is U sine alpha, T is whatever we want to find, and V is 0. This is, of course, at the maximum height. So when it's at the maximum height, we know it travels 1 meter up, and V is, of course, 0 at that point. Horizontally, we know that U is always U cos alpha. Let's look vertically here. We can say that V squared equals U squared plus 2AS. And so 0 is equal to U sine alpha squared minus 2G. And so therefore U squared, so therefore U squared sine squared alpha is 2G, therefore U squared is 2G over sine squared alpha, which is what they wanted us to show. Do not substitute a value in for G. They clearly wanted you to leave that in the answer as just G. Now, horizontally, for part B here, we know that 20, which is the horizontal distance travelled, is U cos alpha T. So, therefore, T is 20 divided by U cos alpha. Just rearranging that. Vertically, and it is important to say whether you're going horizontally or vertically. So vertically, well, S, of course, is minus 1.25. The acceleration is minus G. The initial velocity is U sine alpha, and the time taken is T. So we can combine these two bits of information here. If I use S equals ut plus a half a t squared, then we know that minus 5/4, minus 1.2, is u sine alpha t minus a half g t squared. And so if we call this number 1 and this number 2, then what we're going to do is to substitute 1 into 2, and I need a little bit of space, so I'm going to do it under here. Minus 5/4 is equal to u sine alpha t, but t, of course, now is 20 over u cos alpha, minus a half g t squared, and t squared is 400 over u squared cos squared alpha. So we're now going to simplify this. So therefore, if the board will start working again, which it's not. Okay, come back to me in a second.